now let's start recording. Scroll up, change my pen. Anybody got, while I'm writing this, anybody got any big plans for the weekend other than Kim? We got a big birthday party that I did not get an invite to. Thank you. I'll remember that. Molly and I we would have brought a great gift. I would have got your son Fortnite, and he'd have loved me. So, dividing fractions. Now, there is a method on how we do this, okay? And there's a reason for it. So, what I'm going to do is I'm going to just write out the general way of doing this. So let's say you start off with just two very basic general fractions, which you know nothing about them. A over B divided by C over D. Okay? Now, to do this, step one, you're going to rewrite the first fraction. Pen's a little too thick. Step two, you're going to change division into multiplication. And then step three, you're going to reciprocate the second fraction. And that word reciprocate is just very fancy for flip. You're going to just flip it around. That's it. All right? Now, there's a reason for this. Remember, I'm pretty sure some of us have heard this in the background. Or, I mean, the background. Back in the day. But you never understood why you did it. Here's why you do it. Remember, we can write fraction like this, or division like this. We call this a complex fraction, okay? And there's one thing that we hate is complexity. I like simplicity. When Molly and I got married, I had two requests. That was it. One, I didn't want to be hot. So an August wedding was out the door. We got married October 15th. The second, I just wanted everything to be simple. Because simple means easy. And on a wedding day, the last thing you want is something complex. More complexity, more things can go wrong. So in math, like life, I follow the same rules in math. So the one thing we hate is this denominator right here. All right, we hate dividing by a fraction. Now there's only one number that I can multiply anything by, and I can still get an identity. An identity means whatever you start with, that's what you end with, okay? So, and I know this is going to look weird at first, but I'm going to multiply C over D by D over C. In other words, if you look at this, I have a C in the numerator and a C in a denominator. I have a D in the numerator and a D in the denominator. So this whole thing downstairs turns into what number? Can somebody tell me?
1.
It turns into a 1. Now, according to math, whatever you do to the left, to the right, you got to, do the same. Whatever you do to the bottom, you must do to the top as well. And that is how we get this rule where if you have two fractions and you're dividing them, you keep the first fraction. Notice I keep the first fraction. Division changes the multiplication. And you reciprocate the second fraction. So C over D turns into D over C. Now, if you think about this, dividing fractions is really just multiplying them. You just have to do one step ahead of time. So let's do a really easy example here. 1/4 divided by 1/8. Well, As soon as you establish, oh, I'm dividing fractions here, what you're going to do is rewrite the first fraction. Division changes the multiplication. And now that 1/8 turns into 8/1. Now, it's a multiplication problem. And we know when you multiply fractions, you simplify first. So for that first fraction, 1/4, I'm going to leave it 1/4. And the reason why is because this second fraction, I'm going to rewrite 8 as 2 times 4. Does everybody see why I did that? Like, I'm not going to tell you why I did it. You need to tell me why I did that. Or, if you don't know why I did that, now's the time to ask. Remember, we are all learning this. So, if you don't know, you got to ask.
Because you broke down the 8, 2 times 4.
But why did I break down the 8?
So that you can reduce it quicker. Is that right?
Yes, yeah.
Okay.
In a way, you're right. The reason why I rewrote
because
the
you
8...
can eliminate now the 4s, and now you only have 2/1, which will be 2.
Exactly. Do you see these 2 4s? I got 1 in the numerator or 1 in the denominator. The whole reason why I rewrote 8 as 2 times 4 is so I can do this right now in a red pen. I did it because I know 4/4 equals 1. So I could just scratch them out. Now I rewrite everything exactly how it looks. In the numerator, I have 1 times 2. In my denominator, I have a 1. So 1/4 divided by 1/8 equals 2. So if you really think about this, like I said, what? Dividing fractions is just really one step and then you multiply. Okay? Are there any questions with that? Because we're going to do more examples. It's not like I'm going to do one and call it a day. All right, here's some more. You're going to do them now. There's 1. There's 2. What? Go lay down. Okay, do we need some more time or do we have like some answers? I think we need some more time. Ashley, if you're talking, you are muted. Okay, are we ready? First one should be straightforward. So you're dividing fractions. You rewrite the first. Division changes the multiplication. And you reciprocate the second. Now it's a matter of just simplifying first. So the 4 turns into 2 times 2. And the whole reason why I did that is so I can do this. Now I write what's left over. And it looks like the answer is 2/3. How are we looking so far? Good. Now this next one, I think that's the one that we spent a lot of time on. And I'm trying to get you to not fall into my little trap. Because some of us may have looked at this and started simplifying first. And that would be incorrect. Remember, you got to remember your technique. 5/6 divided by 36/25. Right now, this looks like, oh, I could start simplifying things. No. You got to take care of that division first. So you rewrite the first. You multiply by the reciprocal. And notice here, there's nothing you can simplify. You could break it down if you wanted to, and that's fine with me. You could have broke this down if you wanted to. But notice, all the 5s are in the numerator. All the 6s are in your denominator. Correct? You don't see any of them on top and bottom. Therefore, there's nothing you can do here. So the answer is 125 over, is it 216 or 219? I always forget 6 to the third. 216.
I butchered this.
Oh, you butchered it.
I don't know why I did this, but I carried over, like, so when I rewrote it, I wrote 5 times 5 times 5. I ended up with like 15/81, and I reduced it to 5/27.
Yeah, I don't know what you did there.
What? Okay.
Yeah, because if you look, 5 times 5 times 5 is 125. Do you agree?
Yes.
All right, now 36 times 6.
I know what I did.
Okay, good. Now, here's the big question. That 125 over 216, is it reduced? See, the answer to my question right there, honestly, and I'm just saying this, do not feel bad if you don't see it, but it should happen like that. Is 125 over 216 completely reduced? Yes or no? Yes, it is.
Because the 5 at the end is 5.
Nope.
Oh, okay.
See, this is what makes it's tedious work. This is completely simplified. I can move on to the next and not think about it again. Would you like to know why? Can you simplify anything there? Yes or no? Then why do you think you could do it here? Remember, multiplying fractions. You simplify first, then you multiply. Could we simplify anything here? So you cannot do it here. It just doesn't magically pop up. If you could have done it, you would have done it. If you can't, you can't. Does that make sense, everyone? That's why if you want to... Here, look. I'll even go one step further. Here's our numerator, right? 5 times 5 times 5. They're all prime numbers. Do you agree? Now we have 3 6s in my denominator. Here's the first one. Here's the second one. Here's the third one. Do we still agree? Now, if I just wrote everything in order like I normally would, 3 2s and 3 3s. Does anything cancel? So why do you think it would here? Okay, thank you. All right, thanks, honey. Have a good day. So why do you think would happen here then? Like if it didn't happen here, it cannot happen at the end. I think that's what confuses us sometimes. It's because your whole life, you've always had these fractions. You're like, well, I always got to simplify them. Well, what if you can't? And there goes the question of, am I done simplifying? That should leave us now. And it's because you're breaking everything down first. Okay? Does that make sense? Let's look at another problem here. Seven over 9 divided by 27 over 49. Actually, I'm going to flip that. Let's make it 49 over 27. I'm sorry. Because this one I want to reduce stuff. Okay? So, we're dividing two fractions. First, rewrite the first one. Multiply by the reciprocal of the second. Now this, I'm going to just break everything down. 7 is prime. It stays the same. 9 is 3 times 3. Times. 27. Now that I'm going to do on the right-hand side. Let me draw a little line here. 27 is 3 times 9. And 9 breaks down into 3 times 3. So 27 is going to be 3 times 3 times 3. 49 is 7 times 7. All right. What's my next move here? What if you were me and you were teaching this to somebody, what would you say, okay, do this next?
Go ahead, Stevie.
So you're going to cross out, gosh, I can't even explain it. But you're going to cancel out the 2 3s on top that match the 2 3s on the bottom.
Why?
Because it equals 1.
Good. But that's not the first thing I would do, Stevie, is I would say, how about we just write one big numerator in order?
Oh, yeah.
So 3 times 3 times 3 times 7. And then one big denominator in order. And now I would say, okay, let's look for numbers that are the same in the top and bottom. Because, and I'll be honest with you, I used that word and I shouldn't have. That's a bad word. Cancel is a bad word in math. Because if you think about the word cancel, like on a check, if you go to a restaurant, cancel means it gets rid of. All right? What we're doing here is we're reducing. So the 3 over 3, it reduces into a number 1. Now, normally we don't write it because it's pointless to write a 1, but it's there. So 3 over 3 is 1. 3 over 3, 3 over 3 is 1. This last 3 in the numerator, can I reduce that? Yes or no? So I know that's going to be in my answer. Now the 7, can I reduce that? How many of them? Just 1 or 2? Only 1. Very good.
I have a question.
Go for it.
I feel like you said something, but I forgot why. So when I look at this problem, I immediately want to reduce it first before anything. So like I see that like 7 and 49 can or 49 can reduce anyway. And
Yeah.
Yeah. Is that not a good idea to do that?
No, that's fine. That's fine. I mean, you get the same. You're gonna get the same answer. This
right. I feel like you said not to do that. I don't know why.
The way I'm doing this, Kim, it's just I give you like an additional step because I want you to break everything down. That's it. But I know what you're saying, which is you would have done this.
Yeah, that's how we were taught in the past.
Yeah.
The cross shoelace thing.
Yeah, and you know what you called that? You called that cross multiply, right? And that's incorrect. That's wrong. Cross multiply is when you have a fraction equal to a fraction. There's no equal sign here. It's a fraction times a fraction. So you were wrong, unfortunately. Not you. I'm just saying, it's It's the teacher and the connection you made in your head. That it's incorrect. That's why I don't teach that. Because I know you walking in, you've already heard the words cross multiply. And it's a shame. Because now I got to go into your brain and extract the bad math and try to replace it with good math. So that's why I don't even say it.
You are though. This is helpful. This seriously, like I get this so much quicker than I did in high school.
So here's an image. I'll zoom in. Here's your cross multiply, equal sign, equal sign, equal sign, equal sign. You can only cross multiply if you have an equal sign in between the fractions. Otherwise, you can't do it. So Kim and Stevie, what you're doing over here on the left-hand side of the screen, let me use a different color so you can see it. What you're doing here by crossing this out, putting a 1, crossing out, putting a 7, crossing this out, putting a 3, crossing this out, and putting a 1 is the same exact thing as I'm doing here. It's just you're doing all the work in your head. I'm writing it out. I'm taking that additional 5 seconds, maybe 15 seconds, and I'm writing it out so I can see it. You're applying those divisibility rules very quickly, which is still fine. I will not, push back on that. Just know it's not cross multiplication that you're doing. That's not what it is. You are simplifying. All right?
I'd rather do it your way because once the numbers get way too big, like we had, like 125 over whatever, it's too much to try to simplify at that point. It's easier to write out how you do it.
Stevie, I need to have you and your family just move into my house. That way, when Molly and I are doing something and we're arguing about which way to do it, I would just point to you and then you would say, I'd rather do it his way. I need that in my life. So let's do another one. All right, let's do another one here. I'm going to do negative 20 over. Let's do. It's fine. 24 divided by 12 over 25. This might work out nicely. All right, so here we go. I'm going to help us with this. Hi, beautiful kitty in the morning. Crystal, that cat is so pretty of yours. Really is. What's your cat's name again?
Thank you. His name's Karen.
What is it again?
Karen.
Karen. Like Karen?
No, like the carrot you eat.
Oh, a carrot. Oh, I'm sorry. I thought you said Karen. I was like, wow, that's an interesting name. All right, carrot. I like that. So here we go. Crystal, you're going to help me with this one. There's something in this problem that is brand new that I haven't used in any other problems, and that is this negative sign. So let's get the easy part out of the way. We're going to write our answer right there. What's a negative number divided by a positive number? Do you know?
I'm going to get wrong, but I think it's a negative.
You're absolutely correct. Thank you for going with your gut. It'll be right 90% of the time. So we already know what the sign of the answer is, which means you no longer have to worry about that. Next thing we're going to do is let's go ahead and let's apply our technique now. So I'm going to write 20 over 24 times 25 over 12. Now, if you want to carry this negative down with me, that's fine. In fact, that's probably what I would have done. Like I said, we know the answer is negative, so you don't have to worry about it. From here, I'm going to break everything down, okay? So that 20, and if you need to, draw a little line and start breaking things down. 20 is 4 times 5, and 4 is 2 times 2. So my first fraction here, with a negative out front, is going to be 2 times 2 times 5. My denominator, 24, Well, that's going to be 4 and 6. And that breaks down into 2 times 2 and 2 times 3. Are we all on the same page so far? All I'm doing is prime factorizing. That's it. Now the 25, we could do that one, I think, in our head. That one's just 5 times 5. Okay? And now the 12, well, that's going to be 3 times 4, and then 2 times 2. Okay, how are we looking so far? All right, now, from here, I'm just going to rewrite one big numerator in order. 2 times 2 with 3 5s. Denominator, just one big one in order. 1, 2, 3, 4, 5 2s. And then 2 3s. And now I'm just going to reduce. If I see numbers on the same, top and bottom, I'm just going to cross them out. So I can reduce the first set of 2s. The second set of 2s. Is there anything else I can reduce? Now you just multiply. 5 times 5 times 5 is 125. 2 times 2 times 2. Well, this group is 8. And that is 9. So your result is going to be negative 125 over 72. And you know it's reduced because we did it right here. Is this starting to click like a seatbelt? Stevie, you're making a face.
I know, because I didn't have that many 2s left.
Well, I could have wrote too many.
Yeah, I think you did.
No.
Because now that I'm looking at your work on the side, the 20 there's 2, 24 there's 3, and then there's I messed up. That's me.
Okay.
Because it's unorganized on my paper, I scratched out a bunch of stuff. I need to start using pencils.
Oh, pencils are clutch.
Yeah.
Pencils are clutch. All right. I see. Here's the thing. A lot of us, we don't have cameras on, and as much as I want you to put them on, I will never ever say put them on. But I need to know, add a reaction, click the little thumbs up or whatever you got. Do I have reaction on my thing? No, because I guess my thing is normal. I need to know that this is clicking. Okay, so I'm seeing a lot of reaction now. Thank you for that. Okay. We're just gonna keep doing a couple more because I think we still need practice with this. Okay. Crystal, what do you see in this problem that you're like, oh, come on, floater?
Oh, I was just yelling at my cat. I didn't even look at it yet. Sorry. I guess I would just point out maybe the Q.
Yeah, I agree with you. But here's the thing. You got a technique. So when you take a step back, this problem is really what? What do you think this problem is? When you take a step back and you just look at it. It is a fraction divided by a what? No, it's a fraction divided by another.
A prime number.
Ooh,
Fraction.
yeah, it's a fraction divided by a fraction. That's it. At the end of the day, no matter what I put, it's a... Let me make a point. You have no idea what those symbols represent. All you know is that one's a square, one's a circle, one is a triangle, and one is a star. When you take a step back, when you look at this from 3,000 feet above, you have a fraction divided by a fraction. which means you rewrite the first, division changes the multiplication, you reciprocate the second. If you can simplify, you do it. If you can't, here's your answer. That's it. Do you guys see the point I'm trying to make here? All right? The point is, you got to ask yourself, what type of problem do I have? I have a fraction divided by a fraction. So I know to rewrite the first, division changes the multiplication, and that second fraction I flip. Now, I simplify if I can. Can I simplify here, yes or no?
Yes.
What?
You can cancel out the 3. Oh, sorry. You can reduce the 3's to 1.
Very good, Kim. You can reduce. You caught yourself. I love that. Thank you. Is there anything else I can reduce, Kim?
No, so now it's just 5 over Q.
And that's your answer. And you know it's completely simplified. All right? Is this, like I said, are we starting to click? All right? Let's keep going here. This one's for you. Try that one. Okay, we ready? All right, let's try this out. First thing I see, I have a fraction divided by a fraction. So I know I'm going to have to apply a technique. I also see a negative divided by a negative, which is always a positive. So I know my answer is going to be positive. So what I'm going to do is just put an equal with a circle. That's where I'm going to put my answer. Now, let's rewrite everything. Actually, I said that incorrectly. Let's rewrite the first. Multiply by the reciprocal of the second. Now I try to reduce. Two, 3, and 5 are all prime. There's nothing I can do there. However, that's 6. Its prime factorization is 2 times 3. And the whole reason why I did that is so I can do this. I can reduce those 3's. What's left over? A negative 2 times a negative 2 is a positive 4. And my denominator is a 5. So we get 4 over 5. Does that make sense? All right. All right. Now, I could try to, I guess, make these a little bit more difficult. And what I mean by that is this. What if I gave you mixed fractions? And I said, go ahead and multiply or divide. And what I mean by that, here's a problem. That's a little zoomed in. So here's our first example. 3 1/3 times 5/8. Part of math is being able to look at a problem that you've never seen before, and you try to solve it, or you try to simplify it using techniques that you know. So we've never done this problem before. We've never done a mixed number times a regular fraction. You've always done, a regular fraction times a regular fraction. So this is the thing we got to be concerned about, correct?
It would just turn into an improper fraction, right?
And you just completely taught everybody in the room section 3. Very good job. Because you're right. What we would do is we would need to convert this first. And remember, we do have a technique for converting. It's back here. So let me go back to, what is it? I think it was section 1 or section 2. Section 2. So highlighted in blue right here. I'll zoom in. That's how we convert an a mixed fraction into an improper fraction. We take the whole number, we multiply by the denominator, and we add the numerator. Then we just rewrite the denominator. So for us, I take the whole number, I multiply by the denominator, and I add the numerator. And then it's all over the original denominator. So 3 times 3 is 9, plus 1 more is 10. So this turns out to be 10/3. So now that we did that, I'm going to rewrite my problem as 10/3 times 5/8. I didn't have to flip anything here because I'm multiplying. Now, don't rush. Take it slow. Reduce. What I mean by that is prime factorize. That 10 is 2 times 5/3. The second fraction is 5/2 times 2 times 2. Okay? Now I'm going to write one big numerator in order and one big denominator in order. Lastly, let's reduce by looking for numbers in the numerator and denominator that are the same. There's only one set, and it's the very first. 2/2. So from here, I just multiply. 5 times 5 is 25. And then for my denominator, 2 times 2 is 4, times 3 is 12. Okay? Now, in red, I'm going to write something very, 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 very. How many varies have I said so far?
A lot.
Very important. You want to make sure you follow the directions in the problem. The directions may say multiply and write your answer as a mixed fraction. So, is 25/12 the acceptable answer? No. All right? If it just says multiply, then you just multiply. 25/12, completely acceptable. However, if you see the words, write your solution as a mixed number, then you have to take 25/12 and you need to convert that into a mixed number. And how do we do that? Does anybody remember how to convert from an improper to a mixed?
Divide 12 into 25.
There you go. Kim, have you been studying?
No, I don't know why, but this is just really clicking with me. So
I'm definitely going to chalk it up to me. I'm going to take all the credit. I'm going to be that guy. 12 goes into 25 twice. With a remainder of 1. So, 25 over 12 as a mixed number is going to be 2 and 1/12. And that would be your acceptable answer. And Kim, no. You keep just whatever you're doing right now, it's working. So you are blowing it up today. Maybe it's the birthday. You're all excited. All right. Any questions? All right. I give you one to do now. Try that. I'm almost done working. Daddy's almost done. Then I'll take you for a fun time.
you don't want us to write this as an improper fraction, do you?
Yeah, why not?
Okay.
We'll do both. Because the answer you get is going to be improper, and then I think it's good practice just to convert it back. All right, so I'll give you another minute. Okay, here we go. 3/7 times 5 1/4. Now, the way it looks, I just can't multiply. I need to convert. So this second fraction at 5 1/4, we need to convert that into, excuse me, an improper fraction. So 5 times 4 plus 1, all over the original denominator of 4. So that's going to be 21 over 4. So that gives me 3 over 7 times 21 over 4. How are we looking so far? Pretty good? Did we all get to this step right here? All right. Next. We know we're multiplying, but let's try to simplify if we can. 3 and 7 are prime. 21, I can break down that 21 into 3 times 7. And then that 4 I can break down into 2 times 2. Now, one big numerator, one big denominator in order. For me, it looks like the only thing I can simplify are the 7s. Which means in my numerator, 3 times 3 is 9. My denominator, 2 times 2 is 4. So, There's your improper fraction answer. Your mixed number answer, you would have to divide. So 4 goes into 9 twice with a remainder of 1. So the the mixed number answer would be 2 1/4. These are the same. How we doing, everyone? Pretty good? All right. I be honest with you. The only way you're gonna get better at this is practice. Okay. If you go through, because I'm gonna upload homework now that we have enough to do. Just click on the Ask My Instructor. I can always make a video or something, you know. No problem has the same exact numbers, because if they did, all the problems would be the same. So don't be concerned with the numbers. What you need to be able to do is, like I said, look at this from 3,000 feet and say, okay, what am I given? Well, I'm given a fraction times a fraction, or I'm giving a fraction divided by a fraction. Then ask yourself, okay, well, what do these fractions look like? This is our last example of the day. Two 1/8 divided by 1 1/2. All right, here we have two mixed fractions. To be honest with you, that is no concern of mine. I look at the first number, it's a fraction. I look at the second number, it's a fraction. What's the sign in between? Division. So I know I'm going to have to reciprocate eventually. But I can't do anything until I convert these into something I'm used to. So 2 1/8 is going to be 2 times 8 plus 1 over 8. So that's going to be 17 over 8. So I rewrite 17 over 8 divided by 1 1/2. Well, that's going to be 2 times 1 plus 1 all over 2. So that's going to be 3 over 2. Now, this looks like something I'm familiar with. So I rewrite the first. Then I multiply by the reciprocal of the second fraction. Now, I know I'm multiplying. I'm going to simplify if I can first. 17 is prime. 8 is 2 times 2 times 2. You probably already memorized that one by now, because we see it so much. For the second fraction, 2 is prime and 3 is prime. So now, one big numerator in order. One big denominator in order. I see a 2 on the top and a 2 on the bottom. They reduce. Nothing else reduces. 17 in the numerator. 2 times 2 is 4 times 3 is 12. There's my improper answer. However, if I wanted a mixed number, I just divide 12 into 17. 12 goes into 17 once with a remainder of 5. So 17 over 12, or 1 5/12. And those are your two answers. Does that make sense, everyone? Okay? The math that we're currently studying, 80, 90, even 108, is all about repetition.